Hello friends, I am Dr. Manisha, Assistant Professor from Department of Physics, KVN College, Nasik. Friends, today we'll start the series of lectures for TYBSc Physics Semester 1st, Mathematical Methods in Physics. The first chapter is Curvilinear Co-ordinates, which includes Introduction to Cartesian, Spherical, Polar and Cylindrical Coordinate Systems, Transformation Equations, then General Curvilinear Coordinate System, which includes coordinate surface, coordinate lines, length, surface and volume elements in curvilinear coordinate system, metric coefficient, also orthogonal curvilinear coordinate system, then expressions for gradient, divergence, Laplacian and curl, also the special cases for the gradient, divergence, Laplacian and curl in Cartesian, spherical, polar and cylindrical coordinate system. Friends, any physical problem, we have to deal with several physical quantities like pressure, mass, density, electric and magnetic field intensity, potential and temperature gradient. All these quantities may have different values at different points in space. One has to select a suitable coordinate system in solving such problems. Any reference system used to fix the position of a point in the space is called as coordinate system. There are three coordinate systems which are mostly very common, and these are Cartesian coordinate system, also called as rectangular coordinate system, then spherical polar coordinate system and cylindrical coordinate system. In this topic, we are going to study all these coordinate system in detail. First is Cartesian coordinate system. Any coordinate system which is specified by three mutually perpendicular axes called as a rectangular Cartesian coordinate system. In this figure, the x, y and z axis, these are the mutually perpendicular axes, and all these axes, they are meeting at point O, which is called as origin. The values of the coordinates of this point O are 0, 0, 0, that is x is equal to 0, y is equal to 0 and z is equal to 0. Now we'll consider any point P in the space which is having the coordinates x, y and z. The line segment OP, O is your origin and P is the point in any point in the space. Then this OP can be written in the factorial form as OP bar is equal to R bar is equal to XI bar plus YJ bar plus KZ bar, where these I, J and K, all these are the unit vectors along X, Y and Z axis respectively. Now the magnitude of OP bar, it is given as, now this is the vector, it is the vector notation, and if we'll find out the magnitude of this vector, then it can be written as R is equal to square root of X square plus Y square plus Z square. Now let us discuss the concept of coordinate surface and coordinate lines. Now x dash, y dash and z dash be the coordinates of the point P in the Cartesian or the rectangular coordinate system. Let us consider the different planes. If the plane surface ABCD, friends, just look at this figure. ABCD, this is the one plane surface which is parallel to this YZ plane. This is your Y axis, this is your Z axis and here is your X axis. This plane ABCD, it is parallel to the YZ plane. Now at each point, the value of the coordinate is X dash. Fine, it is same, but the value of y and z is different at different points. So this plane contains the point P which has the coordinates equal to x dash. The ABCD is the plane, at any point the coordinate is x dash. So x is equal to x dash represents the plane surface parallel to YZ plane. Okay. Now consider the another plane, that is HI. Here is H, I, J and K. Now you can understand that this plane is parallel to XZ plane. See, here it is X axis and this is your Z axis. So this is the plane which is parallel to this HIJK plane. Fine. So at each point on this plane, the value of y coordinate is constant again. Let it be y dash. But the values of x and z will be different at the different points. So this plane surface contains the point P which has the y coordinate equal to y dash. Therefore, the equation y is equal to y dash represents the plane surface parallel to xz plane. Similarly, now we'll consider the third plane, that is P, Q, R and S. This plane is parallel to the xy plane, correct? At each point on this plane, the value of z coordinate is now constant. So this coordinate will be z dash, but the values of x and y coordinates will be different at the different points. So this plane surface contains the point P which has the z coordinate equal to z dash. So z is equal to z dash represents the plane surface parallel to xy plane. Now we'll consider the point P. This is the point P which is common to all these three planes, that is x is equal to x dash plane, then y is equal to y dash plane, and z is equal to z dash plane. For all these three planes, this point P is common. This means that P is the point of intersection of all these plane surfaces, so that point P has the coordinates x dash, y dash, and z dash. The surface x is equal to x dash, y is equal to y dash, and z is equal to z dash are known as coordinate surface. Correct? Now, from this figure, the line LM. Now see, this is the line LM which is in the plane of HIJK. This line is the intersection of plane HIJK, that is y is equal to y dash plane. Fine. And PQRS. This is PQRS which is having coordinates z is equal to z dash. Then line LM, this is line LM, it is parallel to x-axis now. And line TU, this is the line TU, it is the intersection of plane ABCD. Correct? This is ABCD plane. Fine? Which is having x is equal to x dash value. And PQRS, that is z is equal to z dash. This line is parallel to y-axis. This is your y-axis. This line is parallel to this y-axis. Similarly, line EF. This is your line EF. This is the EF line. It is the intersection of HIJK and it is y is equal to y dash and PQRS. This is your PQRS. Fine, which is equal to z, which is z is equal to z dash. This line is parallel to z axis. So these lines LM, TU and EF, these all are called as coordinate lines, and thus the Cartesian coordinate system coordinate surface are perpendicular to each other, and the coordinate lines are also perpendicular to each other. The next important concept is spherical polar coordinate system. The spherical coordinate system means in the spherical polar coordinate system, the position of the point is fixed by the three coordinates, that is r, theta and phi. Now friends, first before we go in detail, we must know that the Cartesian coordinate system has the advantages all that all the three unit vectors, that is I, j and k, are constant in the direction as well as in the magnitude. We can use r bar as the radial distance, but even this is treated as the function of xyz again. Unfortunately, all these physical problems are not well adapted to the solution in the Cartesian coordinates. For example, if we are dealing with the problem in the central force, that is gravitational or the electrostatic force, then we write f bar is equal to r bar into f of r. The Cartesian coordinate system will be inappropriate. In such problems, we had to use the spherical polar coordinate system. Hence, the coordinate system to be selected should be chosen in such a way that it fits the problem to exploit any constraint or the symmetry present in it. So, in this spherical polar coordinate system, uh, the position of the point P is fixed by the three coordinates, that is r, theta and phi. Now, we'll study what is r, what is theta and what is phi. As shown in this figure, the three coordinates in the spherical polar coordinates are, see, OP is your R, then the angle made by POZ is your theta, and angle made by QOX is your phi. We'll see in detail now. The coordinate of R, it is the distance of point P from origin, as we have seen that OP bar is equal to R bar and it has the dimensions of length. Then the coordinate of theta, that is the angle theta, it is the angle between OP and vertical Z axis. It is also called as the polar angle. So angle theta is equal to angle ZOP. The next coordinate is phi, the angle phi between the x-axis and OQ, where OQ is the projection of OP on XY plane. See here, projection of OP, correct? Point P is here. It is the projection of OP on XY plane. So angle phi is also called as azimuth angle. So angle phi is equal to angle XOQ. Now we'll see what is mean by coordinate surface. In this figure, the coordinates represents the three surfaces. The equation OP is equal to R bar. It is equal to constant, which represents the surface of sphere with its center as origin. See, here it is. This is the center of origin. Origin of the center, and OP is the radius. Similarly, polar angle theta. It is also constant, represents the curved surface. This is the curved surface of cone with its vertex at origin. This is the origin. Next is azimuth angle, that is phi, which is also constant, represents the surface of the half plane with its one edge along z axis. Correct? The coordinates are theta and phi. This is r, theta and phi. This also represents the three coordinate curves, and the line OP is called as R curve, and R coordinates changes along this line. Now we switch to the transformation equations. The transformation equations between the coordinates in the spherical polar coordinates and those in the Cartesian coordinate system. We'll consider the point P, which is having coordinates x, y and z in the Cartesian coordinate system, and OP is R, then theta is POZ, this is theta, and phi is the azimuth angle, that is QOX. Fine, these are the coordinates of the spherical polar system. Now we'll draw the perpendicular PQ on this xy plane. Fine. Then draw QM perpendicular and QN on y and x axis respectively. This is the construction. The coordinate xyz in the Cartesian coordinate systems are x is equal to ON. See, this is your ON, which is equal to x. Then OM is your y. Now this OM is equal to NQ. Similarly, this ON is equal to MQ. Fine. And this OM is equal to NQ. Similarly, PQ is your Z. This is your Z. It is parallel to this line. So it is Z. Similarly, coordinates r, theta and phi of this point P in the spherical coordinate system are OP is equal to your R, then theta is ZOP and phi is angle NOQ. Now Cartesian coordinates in terms of the spherical polar coordinate system. Now see, in this figure, x is equal to ON. Now this we can write as OQ cos of phi. See, now ONQ is your right angle triangle. Fine. This is your angle phi, because QN is perpendicular on this OX axis. So this is your angle phi. So cos of phi will be ON upon OQ. So ON, we can write ON as OQ into cos of phi. Okay. Now x is equal to r sin theta cos phi, because what is your OQ? OQ is equal to, now in the triangle OPQ, now this is the perpendicular drawn on this plane. Fine. So we can write OQ as r into sine of theta. This is your theta. Fine. So it is r times sine of theta, because this is your z axis and this is also the distance which is equal to z. So we can write x as r sine theta cos of phi. Similarly, for y, it is equal to OM. Here is your OM. Fine. So it is also equal to OQ into sine of phi. This is your phi. So sine of phi will be OM upon OQ. Okay. So we can write y as OQ into sine of phi. Again, your OQ is r sine theta. So y can be written as r sine theta into sine phi. Similarly, this is your z, that is PQ, and it is equal to OP into cos of theta. OP into cos of theta. So z can be written as r of cos theta. So x is equal to r sine theta cos phi, y is equal to r sine theta sin phi, and z is equal to r cos theta. These are the transformation equations, which shows that we can obtain the Cartesian coordinates using these transformation equations. Now we'll switch to the spherical polar coordinate system in terms of the Cartesian coordinates. Friends, as we have seen that x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. If we want to square and add these, we can get x square plus y square plus z square is equal to, now we'll square all these terms and we'll add it one by one. So it is r square sin square theta cos square phi plus r square sin square theta sin square phi plus r square cos square theta. In all these terms, r square is common, but in the first two terms, we'll take r square sin square theta common. So in bracket cos square phi plus, from this it is sin square phi plus r square cos square theta as it is. Now cos square phi plus sin square phi will be 1. So it is r square sin square theta into 1 plus r square cos square theta as it is. Again we'll take r square common, then sin square plus cos square theta will be 1. So your r square will be x square plus y square plus z square. If we'll take square root, then r is equal to square root of x square plus y square plus z square. Fine. Similarly, if we'll take the ratio of y upon x, then y is r sin theta sin phi and x is r sin theta cos phi. R sin theta will get cancelled. We'll get sin phi upon cos phi as tan phi. And if we want to find out the value of this phi, then we can write this phi as tan inverse of y upon x. Similarly, z upon r is cos theta. So theta is equal to cos inverse of z upon r. Fine. Cos inverse of z upon r is again square root of x square plus y square plus z square. Okay. So we'll get now the values of r, theta and phi in terms of x, y and z. So r is equal to square root of x square plus y square plus z square for r is greater than 0. Then theta is equal to cos inverse of z upon square root of x square plus y square plus z square for pi is greater than or equal to theta or greater than or equal to 0. And phi is equal to tan inverse of y upon x for 2 pi greater than or equal to phi greater than 0. All these three equations are the another set of transformation equations. Friends, I hope you can understand each and every concept in this topic clearly. If you like this video, please like and share it. Stay tuned. Thank you.